We're comparing fractions now. Check your thinking against mine. Of course, I want you to have the right answers, but you know well now that the idea is to develop the thinking that allows you to respond to these questions, circling the larger fraction. So how are you thinking in this process? So here's how I'm thinking. 1/3 is one copy of 1/3. Take a whole, cut it up into 3 equal parts. Imagine one of those parts. 2/3 is 2 of those 1/3. And so clearly 2 of the 1/3 is bigger than 1 of the 1/3. Or 4 of the 1/5 is bigger than 3 of the 1/5. 6 1/7 is more than 2 1/7. Now, as you work on this, you may look at the virtual manipulatives and see it. Remember back in activity 2, the more pieces it takes to cover the circle, the smaller the pieces. And so we're comparing things like 6 of those 1/7 to 2 of those 1/7. 6 of them would be bigger. 11 1/12 would be bigger than 8 1/12. Now what happens with 2/7 and 2/9? Now we really have to think. They're both 2 copies of something. 2 copies of 1/7, 2 copies of 1/9. Now, back to activity 2. If you cut something up into 9 equal parts, each one of those parts is a 1/9. Since it takes more pieces to cover the circle, the pieces must be smaller. So here I have 2 1/9, which are smaller than 2 1/7. Taking a whole and cutting up into 7 pieces, reflect back to activity 2. If it takes 7 pieces to cover the whole, they're going to be larger than the 9 pieces that it took to cover the whole. And so 2 copies of 1/7 is going to be bigger than 2 copies of 1/9. Or 4 copies of 1/6 are going to be bigger than 4 copies of 1/8. You see the thinking. We're thinking about what a fraction is. We're thinking about cutting and copying. And cutting up into 8 pieces means smaller pieces. Cutting up into 6 pieces means bigger pieces. And so the 4, I don't know why I circled them both. I was talking, huh? So the 4/6 is going to be bigger than the 4/8. All right, what about 1/4, 3/4? Oh, 3 copies of a 4th is going to be bigger than just 1 copy. 2/7, 2/6. 2/7, 2/6. Cutting things up into 7 pieces compared to cutting things up into 6 pieces. Oh, the fewer the pieces, the bigger the pieces. So 2 of the bigger pieces is bigger than 2 of the smaller pieces. Aha. 4/12, 4/15. Ooh, cutting up into 15 pieces. They're going to be small pieces. 4/12, not as small. So this is going to be bigger. 6/7, 3/7. Oh, 6 1/7 is going to be more than just 3 1/7. And 9 1/10 is going to be bigger than 3 1/10. There I go again, almost circling them both. All right, do you see the thinking? We're thinking about what a fraction means to make the comparison rather than some algorithm, some trick, some other strategy. If you've been using some other strategies, I don't know what they are. You can email me and tell me, but I would encourage you to consider, are you thinking about what a fraction really is? Are you remembering some algorithm, some procedure that helps you get the right answer, but do you really understand why that answer makes sense? All right, what about these? 13 1/100ths versus 27 1/100ths. Well, 27 copies of a 1/100th is going to be bigger than only 13 copies of a 1/100th. 9 10 Now look, notice these common numerators. Did you notice that when you have a common numerator, that helped us to make the comparison as well? Here I have 9 copies of something, and here I have 9 copies of something. What's the something? Well, cutting something up into 100 pieces are going to make the pieces really smaller. The more pieces you cut the whole up into, the smaller they are. Compared to cutting up into only 10 pieces. So 9 copies of the 1/10 are going to be bigger than 9 copies of the 1/100th. Now, let's see. I'd like you to come over here. Here I have some common numerators. I missed these before. 2/3, 2/8. Cutting things up into thirds. Less pieces, bigger pieces. More pieces, smaller pieces. And so 2/3 will be bigger. 7/10, 7/9. So that's a close one. But still, cutting things up into 10 pieces compared to cutting things up into 9 pieces, the one whole, the big circle, if you will. Cutting things into more pieces makes the pieces smaller. Less pieces makes the pieces bigger. And so 7/9 will be bigger. All right, now, suppose you are about a fifth grader. And as a fifth grader, suppose I gave you that. Actually, I'm going to give you one that's a little challenging here. Suppose I asked you to consider 11/12, and I'd like you to compare that to, let's go with 10/11. Notice I didn't give you common numerators, nor did I give you the common denominators. I just want you to think. I'm going to pause here for a minute. You try something that makes sense, and then come back and we'll talk. Did you try it? Did you try it? Let's see. Here's one strategy that might work. Can you imagine 11/12? Imagine a circle cut up into 12 equal parts. I'm not going to do it, but if I cut that up into 12 equal parts, they're going to be pretty tiny little pieces. So there would be one of the 12, so I have 11 of them. And now imagine cutting up into 11 pieces. Cutting up into the fewer pieces is going to make the piece a little bit bigger. Now, this is not to scale or anything, but cutting things up into 11 pieces makes the pieces a little bit bigger. So in this case, that guy right there is a 1/11, where that guy right there is a 1/12. Now, a 1/12 is going to be smaller than a 1/11. So this sliver right here is going to be just a smaller piece of the whole. And so a smaller sliver is going to make me closer to one whole. This is going to be a bigger piece, and so a little bit further away than one whole. Since this one is closer to one whole, then you can see my mouse. Since this one is a smaller piece, 1/12 compared to 1/11, this one is closer to filling in the whole circle than this one. Therefore, this one is going to be bigger. Do you see that? So a strategy for comparing fractions when they're really close to one whole is to see how close they are. Now, another strategy would be something like this. Let's do 3/5 versus 4/7. 3/5 versus 4/7. They're really close, but this one, let's see, 3/5, that would be cutting up a circle up into 5 equal pieces and taking 3 of them. I'm 2/5 away from a whole. Here I'm 3/7 away. And so pause the video for a minute and see if you can use that. How close to 1 are you in order to determine which of those two fractions is bigger? I'm going to give you a minute. Let your brain think. Let your brain productively struggle through it. Pause the video and then come back and see how you did. Now, here's a strategy that's possible here as well as the how close to 1 are you. Here's another strategy. The common denominators and the common numerators we saw up here throughout the test kind of made things nice. And you're so used to common denominators, I'm not going to go there right now. I'm going to have you do a common numerator approach. Can you imagine this? So 1/5. Can you imagine breaking this circle up into fifths and taking each of those fifths and breaking them up into 4 pieces each? So can you imagine each of those fifths having 4 in there as well? Now, why 4? Because I want us to think about 3 of those fifths, each one of those fifths broken up into 4 pieces. So 4 pieces here, 4 pieces here, 4 pieces here. That would be a total of 12. And if I did that to all of the fifths, 4, 4, 4, 4, 4, there'd be a total of 20. That is, 12/20ths would be the same thing as 3/5. Why? Because I took each of the 3 copies, broke it up into 4 smaller pieces each. 4, 8, 12. I did that for all of the fifths. 4, 8, 12, 16, 20. So 12/20ths and 3/5 are the same thing. Now come over here. Imagine the 4 sevenths. And I'm going to take each of the 4, 1, 2, 3, 4, pretend I did this accurately, and I'm going to break it up into 3 pieces each. So 3 here, 3 here, 3 here, 3 here. Now why 3? 3, 6, 9, 12. There'd be 12 of those as well. Do you see where I'm going with this now? The common numerator approach. Now if I did that to all of the sevenths, broke them all up into 3 pieces each, 7 groups of 3 would be 21. So now I'm comparing 12 20ths to 12 21st, and now I can do it like I did some of the work up here with common numerators. Let's see. Here I have 12 copies of 1 20th. Here I have 12 copies of 1 21st. Same number of copies, but breaking up the whole, that whole circle into 21 pieces, the pieces are going to be smaller. Breaking the pieces up into 20 pieces, relative to the 21, these pieces are going to be bigger. So 12 of the bigger pieces is going to be bigger than 12 of the smaller pieces. So this is bigger, which means this is bigger. Hey, again, there's lots of ways to think about this. There's different strategies. I just wanted to present with you a couple that I've seen when I've done this with groups of people. There's different ways that we can compare fractions that engage the brain in really good thinking, not just mimicking some algorithm.